Okay, so in this video we're going to talk a little bit more about graphing the sine, cosine, and tangent functions. We'll review a little bit of what each of the transformations does, and then I just want to give you some practice problems and then some immediate feedback on those so you can kind of compare where you're at. So the first thing I want you to do is take a look at this exploration activity. So click on that link, and it's going to take you to this screen right here, and I want you to pay special attention to just a couple of things. The first one is what effect each of these four transformations has on the actual graph. So when you change A, what happens? When you change B, what happens? When you change H or K, what happens? We've done that before with other functions, and these variables all have the exact same effect on the sine and cosine and tangent functions as they do on any of the other ones. But in this particular graph, I want you to just pay special attention to those, especially those three that we've talked about specifically: the amplitude, the period, and then the phase shift. And so these green lines here represent the whole range of the function. But one thing I want you to remember is the amplitude is only that distance from the red line up to the green line. So how does the A value there affect the amplitude? The B value affects the period, so that's shown by these blue lines here on the screen. So when you change B, how does that affect the amplitude? Or sorry, the period. H is our phase shift, so how does that affect the graph? When I move H in the positive direction, what happens to my graph? When I move H in the negative direction, what happens to my graph? And then K, again, is just your vertical shift. So this is pretty much the exact same thing that it's been doing forever. These lines on the screen, of course, match up with the lines that I've been drawing on the graphs the whole time. So your midline of your graph is where this whole thing is centered around. As you move up or down, you can see that the graph stays centered at those points. The green lines represent the range of the function, and so as I change the amplitude, the range changes as well. B affects the period, so as I make B greater, you can see the period changing. One of the best ways to tell the period is just to look for the starting point of the graph and where you get back to that same starting point. And then H, that's your phase shift. Of course, it goes the other direction from what you'd expect. So, real quick, we're just going to do a couple of these. We're going to start taking a look at this one here. So at this point, what I'd like you to do is to pause the video. At any point in time, if you're stuck, you can of course resume it, and I'll kind of show you what's going on. But I would try this on your own first. So go ahead and pause the video, and then when you're ready, go ahead and hit resume. So, hopefully you've tried this out already on your own. But I'm just going to go through how I would graph this real quick. If I'm graphing this, of course I'm starting with my x and y axis. The first thing I'm going to look at is my vertical shift. And so that +1 is going to tell me that this whole graph has moved up 1 unit on the graph. And then the next thing I'm looking at is that 3. And so what that's telling me is that from there, that's my amplitude. Think of those green lines I just drew on the Desmos activity. Those lines are showing you the vertical shift. And so from that amplitude, the amplitude. So from that line for the vertical shift, we're going up 3 units and down 3 units. 1, 2, 3, which will go down to -2. And this is showing you the range of the function. At the top here, you've got the highest point you're ever going to get to. Down at the bottom, the lowest point, and then in the middle, that's where your graph is centered around. The next thing I'm going to look at is that -45. That is my phase shift, and so that is going to go 45 degrees to the right. And so on my Desmos activity, that was a blue line. And then the 2 is going to change my period. And so the period here is 180 degrees because it's twice as small as it was before. So from 45, if I travel 180 degrees, that's going to get me to 225. And so that's where my first period is going to end. Now from here, if you remember back to the Desmos activity, graph of sine starts and ends right at that midline, and in the middle it's right at the midline. And so on this graph, I'm going to start at the midline. Oops, purple. Start at the midline, end at the midline. Halfway through, which in this case I think would be 135 degrees, is right at the midline. And sine, if you look back here, starts by going up and then goes down at the end. And so we have our high point and our low point to graph our sine function. And of course this is going to keep going, repeating over and over and over again. You can also see, if you take a look at this Desmos activity, what you can do is go ahead and type these same things in, if I change this to 3, change my b value to 2, h was minus 45, and k was plus 1. You see we have the exact same graph there. Next up, go ahead and try this one. This is a cosine graph. Give that a shot, pause the video, and then come back when you're done. Okay, so hopefully you've given that a shot. Let's just take a look at what I would do if I'm looking at this. So the first thing again is your vertical shift. So I'm going to go ahead and graph that. It's down 1. And again, this is the midline of my graph. The next thing I'm looking at is my vertical stretch of 2. And so this is going to tell me that I go up 2 and I go down 2. That's my range of my function. So in this case, my range would be from -3 to +1. And so that shows me my high point, my low point, and my midline. Next thing I've got is the minus 90, which is going to move my graph to the right 90 degrees. So let's just say that's 90 right there. And then the last thing is the 1/2, which is going to change my period to 720 degrees, which will make from 90 degrees out to 810, somewhere way out here. So again, just 720 plus 90 will get you way out there. Now with the cosine graph, I don't have a Desmos activity here, but if you created another one, you could see the same kind of thing. Cosine normally, I'll do this in yellow, this isn't the real one, normally starts and ends at the top. And so my cosine function would look something like that. Now here, we've got that -2. So that's not what the yellow one is, not with the -2. What's going to happen differently is the graph's going to start and end at the bottom, and it's going to hit the top in the middle. Just a mirror image. So this whole graph, because of that -2, would look like that purple graph there. And again, it would keep going in both directions. Finally, we've got our tangent graph. And just so we quickly recall this one, tangent graph normally has a period of 180 degrees, and it goes 90 degrees in each direction. So we got -90 to 90, and then the tangent graph goes like this, goes right through the origin, and at 45 and -45 hits 1 and -1. So with our transformations, go ahead and try to graph that real quick. Pause the video, and then come back when you're done. Okay, so graphing this tangent function here, put that in the middle. First thing you're going to notice is we've got the +1, which, same as always, is going to move that midline up 1. Everything's just going to be based off of that. And we've also got the 3. What means that hasn't changed here is our period. Still 180 degrees, which means we're going from -90 to 90, and we haven't gotten a phase shift at all. So, drawing those asymptotes. The difference here is that we've shifted that graph up 1, and so our center point there is at 0, 1. And when we go out to our quarter waypoints, in this case 45 and -45, we'll graph up 3 because of our vertical stretch, and down 3. And so our graph will go through that point, that point, and that point. And we can sketch our tangent graph in like that.